Hello, let's look at this question on stoichiometry. Calculate the mass of H2SO4 present in 24 exponential 23 molecules of H2SO4. See this stuff that's written here? It's as good as this, 24 times 10 to the power of 23. Okay, that's what that stuff means. So this is the amount of molecules that you have of H2SO4. We're trying to find the mass of H2SO4 present here. According to Avogadro's principle, 1 mole of a substance like H2SO4 should contain 6.02 times 10 raised to the power 23 molecules. Okay, but the same 1 mole of H2SO4 is equivalent to its molar mass. And what's the molar mass of H2SO4? If you should calculate the molar mass of H2SO4 this way, H2SO4, let's do that. 2 times 1, and then sulfur is about 32, and oxygen is about 16. To calculate all this, you have around 98 grams per mole. So this means that 98 grams of H2SO4 is the mass of 1 mole of H2SO4. Okay, so I've written 1 mole of H2SO4 here. I can as well write 98 grams if I want. So let's just bring it over here now. 98 grams of H2SO4 is the mass of 1 mole of H2SO4, and that contains 6.022 times 10 raised to the power 23 molecules of H2SO4. So if we have 24 times 10 raised to the power 23 molecules of H2SO4, and we want to calculate the mass of that, it will be 24 times 10 raised to the power 23 multiplied by 98, now divided by 6.022 times 10 raised to the power 23. So you see, this is just arranging it in a very good way so that you have your answer X as the mass. To do this very well, you should have around 390.567 grams, which is approximately 391 grams if you want to leave it that way. Yes. Okay, so that's what we have as our answer here, and this is it. So I'll see you on question 42. Bye-bye.